Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Syafiq Zazalini bin Muhammad from Group 4. Today we are going to present about the structure analysis. The introduction of structure analysis. Structure analysis is the process of calculating and determining the effect of load and internal force on a structure, building, or object. Structure analysis is especially important for structural engineers to ensure that they fully understand the load paths and the effect of the load on their engineering design. It enables to engineer or designer to ensure that the piece of equipment or structure is safe for use under the anticipated load. Structural analysis can be performed during design, testing, or after construction, and will generally consider the material used, structure geometry, and applied load. Individual structure element and the force they experience are typically examined in structure analysis. Structure analysis results for beams, slabs, cables, and walls will be reviewed by a structural engineer. While loads, these loads such as self-weight and live load are all applied to all these elements like people or vehicle. As a result, it is critical for the engineer to examine how each these element behave under this load. This is the primary goal of structure analysis. Next is the background of the study case. In structure analysis, there are two methods how to analyze the structure. First, you can use method of joint. The method of joint is a method for calculating the unknown force acting on the truss member. The method focuses on the member's joints or connection point, and it is usually the quickest and easiest way to solve all the unknown force in a truss structure. By labeling the members and joints in your truss is usually helpful at first. This will assist you in keeping everything organized and consistent in subsequent analysis. Then draw a free body diagram in the entire truss structure, write out the equilibrium equation, and solve for the external reaction force acting on the truss structure. The analysis should be identical to that on a single rigid body. Assume that each of connection point between the small members has a pin or some other amount of material. Any external reaction or load force that may be acting at the joint must be considered in your free body diagram. A normal force is applied to each of two force members connection that joint. We also have a guess that it will be a tensor or compressive force. An incorrect guess, on the other hand, will simply result in a negative solution later on. A common strategy is to assume that all forces are tensile and that any positive force will be tensile force and any negative force will be compressive force later in the solution. Each force in diagram should be labeled, include any known magnitude and direction, and give each unknown a variable name. Make a list of the equilibrium equation for each joint. The joint should be treated as particle with force equation but not moment equation. We should be able to generate a high number of equations as a result in this. For each of the joint, the sum of force in the x direction will be 0 and the sum of force in y direction will be 0. Next is the method of section. The method of section is a technique for determining unknown force operating on truss component. The procedure entails dismantling the truss into individual parts and evaluating each one as a rigid body in its own right. the method of selection is frequently the quickest and the most straightforward method of determining unknown force acting in a specific class member. Labeling the members of your class is usually helpful at first. This will make it easier to keep everything organized and consistent in the future. Draw a free body diagram, write out the equilibrium equation, and solve for the external corresponding force operating on the structure system. Treating the entire class structure as a rigid body, this analysis should be comparable to that of a single rigid body. After that, envision dividing your class into two halves. The cut should go through the members which is you seeking to solve for the force as a few other members as possible. The cut does not need to be a straight line. Then, either one or both of the sections you construct, make a free body diagram for each portion. You made a free body diagram of write out the equilibrium equation because there are extended bodies. You will need to write a force and moment equation down. You will have three possible equations for each section, two force equations and one moment equation, which is sum of force equal to 0 and sum of moment equal to 0.
Next, I will be presenting about the basic theory. The set of mechanics theories that obey physical laws required to study and predict the behavior of structures is known as structural analysis. Structural analysis is concerned with engineering artifacts whose integrity is largely determined by their ability to withstand loads. The fields of mechanics and dynamics, as well as a variety of failure theories, are all included in structural analysis. The primary goal of structural analysis, from a theoretical standpoint, is to compute deformation, internal forces, and stresses. In practice, structural analysis reveals the engineering design's structural performance and ensures the design's structural integrity without relying on direct testing. Mechanical and aerospace engineers are frequently faced with the task of designing mechanical systems and components that can withstand operating loads, meet functional requirements, and last longer. It is critical that these structures use the least amount of material possible to reduce costs and improve the mechanical system's efficiency, such as in terms of fuel consumption. Because of the need for strength and efficiency, the geometry of these load-bearing structural components is usually complicated. The structural engineering must determine structural loads, geometry, support conditions, and material properties in order to perform an accurate analysis. Support friction, stresses, and displacement are common outcomes of his or her analysis. After that, the data is compared to criteria that indicate failure condition. Dynamic response, stability, and non-linear behavior are all things that advanced structural analysis can look into. Analytical methods employ analytical formulations that, in most cases, apply to simple linear elastic model, result in closed-form solution, and can be solved by hand. Material strength, energy methods, and linear elasticity are examples of such methods. Numerical approaches such as FEM are better suited to structures of any size of complexity because they use numerical algorithm to solve differential equations based on mechanics theories. The formulation is based on the same three fundamental relations, regardless of approach: equilibrium, constitutive, and compatibility. When any of these relations is only partially satisfied or is an approximation of reality, the solutions are approximate. In the modeling and analysis of structural components, There are always uncertainties. In order to design more reliable mechanical system, it is critical to account for these uncertainties.
Assalamualaikum and good morning. My name is Muhammad Imran Haziq and I'm going to present about analysis and calculation. In this analysis, we are going to use method of section to solve this problem. Step 1, we have to find out the reaction forces, that is external forces for A and L. Sum of MA equal to 0, equal to -5 meter multiplied by 6 kilonewton minus 10 meter multiplied by 6 kilonewton minus 15 meter multiplied by 6 kilonewton minus 20 meter multiplied by 1 kilonewton minus 25 meter multiplied by 1 kilonewton plus 30 meter multiplied by L. And the result of that is L equal to 7.5 kilonewton upwards. Using a sum of Fy equal to 0 equal to -20 kilonewton plus 7.5 kilonewton plus A. And from that we get A equals to 12.5 kilonewton going upwards. Next, for step 2, we have to make an imaginary cut through members FH, GH, and GI and take the right hand section as a free body diagram for calculations. For the next step, we have to use the equations of equilibrium to determine the required member forces. As such, members moment of H equal to 0. That is 7.5 kilonewton times 10 meter minus 1 kilonewton times 5 meter minus FGI times 5.33 meter. And we get that FGI equals to positive 13.13 kilonewton. That is the same as 13.13 kilonewton in tension. For moment, in order to find FH, we have to use moment at G equal to 0 equal to 7.5 kilonewton times 15 meter minus 1 kilonewton times 10 meter minus 1 kilonewton times 5 meters plus FH cos 28.07 degrees times 8 meter. We get members FH equal to 13.82 kilonewton in compression. Lastly, to get GH, we have to use moment at L equal to 0 equal to 1 kilonewton times 10 meters plus 1 kilonewton times 5 meters plus FGH cos 43.15 degrees times 15 meters. And lastly, we get FGH equal to 1.371 kilonewton in compression. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Sharifin Zulkifli and my matrix number is AA212741. And today I want to talk about discussion. Okay, a truss is a structure that is very often applied in the engineering, such as bridge, steel buildings, and structures. All members of truss structure are connected together with a beam joint. All external load acting on the truss are assumed to be acting only at the joints, but therefore all the members of a truss are two force members. The individual members are not subjected to bending moment and share forces, but are subjected to only axial forces, that is either compression or tension. Next is the conclusion. The truss is a building invented that allow the weight of the roof is to be distributed to the outer wall for the better support. Truss give more support and allow the builders to use fewer materials to achieve any construction. It allow distribution of load. It increases the lifespan of any construction like bridge or building. Trusses also have some disadvantage. In truss bridge, it takes up more space and sometimes more distraction to drivers. It also have higher maintenance demand of all joint and fitting, more calculation to determine that it will take the maximum load. That's all from me. Thank you.